Welcome back. Okay, today I figured just for fun, let's do a turtle program and trinket.io, turtle.py. This one's it was gonna be for Pi Day, but I was out sick Friday the 13th, March 13th, and then we closed school on Monday the 16th. So we've been away from school for 4 weeks. This is almost the end of the fourth week already. We started teaching on that Tuesday the 17th. It wasn't a full week, I guess, the first week, whatever. All right, so anyway, this is a way to estimate pi. Sort of crazy. Think of a dartboard. You can throw the dart anywhere on this board. Now, this board is a square. Okay. Now, you're going to throw let's say you can throw the dart randomly anywhere in this square. Okay. But inscribed in the square is a circle. So think about it. What if the circle is of radius 1? What's the area of a circle of radius 1? Well, pi r squared would be pi times r1 squared is pi. So the area of the circle is pi. Now, if the circle is inscribed in the square, then one side of the square would be the diameter of the circle, which is 2. What's the area of a square of side 2? Side times side, length times width, base times height, 2 times 2, 4. So what's the probability of, at random, hitting somewhere in the area of the circle compared to the area of the entire square? This is probability like we've been doing in chapter 8, right? So I would say the area of the circle versus the area of the square, pi over 4. So what I'm going to do is I'm going to throw a bunch of darts and randomly all over the board. You can't miss the board, but you can miss the circle inside the board, which is a big square, right? And count how many times it got into the circle compared to how many times I threw the darts, and that should be an estimate for pi over 4. If I want an estimate for pi, I could then, of course, just do multiply that answer by 4, right? So that's what I'm going to do. So let's go to Trinket. I just created a new trinket here. I don't know if I'm going to save it, so I'm not going to title it, but I did. All right, let's title it. Find pi.py. Hey, find underscore pi.py. Okay, there you go. All right, so what are we going to do? All right, well, first thing we got to do, of course, is import stuff. So I'm going to import turtle, and I'm going to import random, because I'm going to need random numbers to figure out where the darts fall. Okay. All right, so let's set up a turtle. Let's say my pen equals turtle.turtle, the turtle class, the turtle constructor. We'll talk more about classes and constructors and objects and things in Java next year. Okay. Let's see now. Let's make also a window. Let's make a window equal to turtle.screen. You didn't have to do this. I was just playing around with this. So constructor capital S screen. And so that way I can manipulate the window a little bit. Let's say we make our window background color. Let's make it white. And remember, white would be string, hexadecimal numbers, all red, all RGB, right? All red, all green, all blue, turned on. Okay. So if can I just run that much? I got a white background. Good, there it is. Alrighty. Now, what I want to do is draw the square. Let's see, how would we draw the square? Now, on here, I was talking about a circle of radius 1 and a square of side length 2, but I'm using pixels here, right? So how about if I make the radius of the circle, let's see, radius of the circle, let's make it, I don't know, 180 pixels on the screen. So if I draw the square around the circle, it's going to go from negative radius to positive radius. Let me see, how am I going to do, how did I draw the square? Negative radius, positive, so negative 180, positive 180 would be the top left-hand corner. Okay, and I'm going to start there, drawing there, and then I'm going to draw the square like we usually draw a square. Okay, that sounds good. I'm just looking at my notes how I did it. All right. So draw the square from starting at negative radius, comma, positive radius. Okay. Now remember, when we use the window screen, the center of the screen is 0, 0, not the top left-hand corner. So the top left-hand corner is negative 180, positive 180, right? I think so, yeah. And then we're going to make it 2 times radius wide. Okay, let's see if we can get draw square to work. All right, so I'm calling draw square. All right, how about if I make my little functions up here? Okay, so draw square. Let's think about this. So define the function draw square. Okay, that square is going to start at the top left-hand corner at x comma y, which is at negative radius comma positive radius, right? X comma y. And it's going to have a width of 2 times the radius, right? So I call that width, let's say. All right, so how about we make my pen pick up the pen so it doesn't draw anything while it's moving right now. Alrighty. Okay, that's that. And then let's go to that top left-hand corner. Let's make the pen color black now. And let's make it sort of thick. How about pen size 3? You can change this if you want. My pen dot pen size 3 pixels wide. Just make it stand out. And let's make it black. My pen dot color is a RGB string in hexadecimal. How about 00 for red, 00 RGB green, and 00 for blue? So that would be black, right? Now let's put the pen down. You could abbreviate this like, was it PD? Alrighty. Then let's do a for loop. I want to do 4 sides, right? So let's do a for side in range 4. Right? Remember that counts integers from 0 to 3. So that'll make my loop iterate 4 times. Let's go forward with and then turn right, and let's do that. Let's do that a whole bunch of times. 4 times, right? So how about my pen dot forward width. Okay. And so it's a top left-hand corner, and it's facing east. So it's going to go to the right, the width, 2 radii. And then I'm going to turn right 90 degrees and do it again. So let's see, my pen dot right 90 degrees. We're in the degree mode here. And all right, let's see if that works so far. There you go. There you go. So filling in most of the screen here, right? There you go. Perfect. Perfect. All right, that's how the window, how the screen constructor works in Turtle. Okay, so in the middle of that black box are the coordinates 0, 0. The top left-hand corner is negative 180, comma 180. And then we went 360 to the right, turn right, 360 pixels down, turn right, 360 pixels to the left or west, I guess. Turn right, 3 pixels up or north. Okay, there you go. Perfect. Let's do the same thing with the circle. All right, so let's draw a circle inscribed inside the square. So draw circle. Let's see. Let's make it tell it where the center is and the radius. Right? Or, well, what center do I want? Oh, okay, let's make it 0, 0, and the radius is 180. Okay, so let's go up here and write the method draw circle. Okay, so define draw circle inscribed inside the square, right? So it's going to start with the center given as x and y coordinates, and then whatever the radius is. So how are we going to draw a circle? There is a circle command, I think, right? All right, let's try this. All right, so depending where you are on your graph, how about if we, whoops, colon, well, how about if we pen up, right? Pen up method or function. Let's go to, where are we going to go to? We're going to go to x. How about, all right, this is how the circle command works, I think. If you start in the circle, right? The leftmost point, and then you draw from there. I think that's how it works. Let's try this. Okay, so let's start. Okay, this is what we're going to do. I'm going to start at x. Okay, here we go. Let's go to my pen dot go to. Let's keep that x value, but let's go. We got to go to where the circle is. Either let's go to the left, it would be x minus radius, or to the right, x plus radius, or up, y plus radius, or down, y minus radius. All right, how about this? Let's start at x, which is 0, comma, y minus radius, which is going to give you 0 minus 180 or negative 180. So let's start there. All right, let's make the pen size. Depending on what we call in what sequence, I don't know if the pen size is set to 3 still at this point, so I'm going to make sure my pen size is still 3 before I start drawing. All right, I'm going to make the color black, because the thing is, later what I'm going to do is I'm going to color the darts that fall into the circle red, and the darts that fall outside the circle blue. So depending on when and if we draw a circle or draw square, I might have changed the colors at some point. So let's make sure the colors are correct. My pen dot color is still black. Okay. Now let's pen down. We could write a crazy loop to draw a circle, like a square with very short sides and a whole ton of them, right? So, but that's a mess. I'm not going to do that. Pen down, right? Alrighty, and then let's draw the circle of radius, whatever you want. Okay, so draw. So my pen circle radius. My pen dot circle. I think this is a circle command. I'll draw a circle of radius, what, at 180 in this case, starting there. Okay, so let's see if that works. Circle and radius, whatever was passed to the function. All right. Let's see how that works. Here comes the square again. Should I set the speed 0 or whatever? Is that as fast as it goes? Does it default to speed 0? I don't know. Maybe we should try speed 0. I could hide the turtle too, I guess. That's right, for debugging purposes. Right, bottom of the circle, and then draws a circle kind of clockwise. Oh, it goes clockwise, really? But there it is. It's inscribed in the square. That's what I want. All right, perfect. So now I'm going to generate a bunch of random points, and then I'm going to plot those as dots, in other words, where the dart hits the board. And if it's in the circle, I'll color it red. If it's outside of the circle, I'll color it blue. And what we're going to do is calculate the number of reds divided by the number of tosses, or the reds plus the blues. How's that? Does that sound good? Just for fun, let me go in here and set the speed to 0, see if that makes any difference. How about here? My pen dot speed, is it speed? Yeah, speed 0. And how about we just hide the turtle? Can we hide the turtle? Let's hide the turtle. So my pen, for debugging purposes, maybe I should leave it on. All right, let's see what happens. Hide turtle. Now let's see what happens. Run. Is that any faster? No. What happened? I spelled hide weird. Yeah, that was great. So good. Whoops. All right, let's try that. Well, that was pretty quick. Wait, just for fun, let me not hide the turtle for a minute. let's not hide the turtle for a second. I got a hashtag comment and see how fast it goes. Oh, it goes pretty fast. Oh, that's good. I like it. Okay, nice. All right, so I think I'm gonna make it that fast. I'm gonna make it really fast. Good. Perfect. Nice. Okay. All right, so now what are we gonna do? Let's say I make a bunch of dots. Now I imported random, right? So I can do rand int from negative 180 to positive 180. It'll give me all kinds of random integers between negative 180 and positive 180. I'm not sure if that's inclusive. May not be. Then we have to figure out if that point that we generate is in the circle. Now the circle is going to be, well, what we want to do is figure out the distance from the center of the circle to the point and see if that distance is less than the radius. If it's still less than the radius, we'll color that dot red. And if it's greater than the radius, we'll color that dot blue. We'll draw it with that color. And then we're going to figure out the probability. Okay, I think we're good. So let's, down here, okay, let's go over here. Let's do that. Down here, I'm going to do this. I'm going to say, all right, so I drew the background, basically, the circle and the square. All right, so now 4 dots in range. Let's say from 0, let's do 100 dots, 100 tosses. 0, make it, 100, why not? Okay, so there'll be 100 tosses, right? Let's generate a random x and y value. How does that work? Well, we're going to use random dot rand int from negative radius, we set that to 180, right? To positive 180, positive radius. We could change that line 28 and just change the whole program automatically. So that's why I'm not using naked data values. I'm using descriptive constant variable names, right? So here we go, radius, that's preferable. All right, so there's that. And then y is going to be the same thing, hopefully a different random number. Somewhere between negative 180 and positive 180 for y, negative 180, positive 180 for x. Then let's calculate how far it is from the center. Now remember, the distance formula is just x2 minus x1 squared plus y2 minus y1 squared rooted. But we're going from 0, 0 to xy. So x minus 0 is x squared plus y minus 0 is y squared. Square root that. Okay, so how about we say the distance that point is from the center of the circle is, now we could do squirt, we could do math.squirt of x squared plus y squared, or, and remember we're strictly Pythonic because can't do the caret 2 for squaring. Or how about this? Quantity x squared plus y squared to the 1/2. Isn't that square root? So we don't have to use squared, just for fun. All right, so then, what are you saying y is not defined? The hell are you talking about? How is y not defined? That's strange. All right, whatever. I don't know what that means. Go away. Can you go away? Oh, is that from before, maybe? All right. All right, so here we go. So if the distance from the center to xy, that point, is less than radius, let's set our color. Let's set our color to red. Okay, and let's count it. Let's say total in circle plus equals 1. So I guess I should initialize total in circle to 0 out of here. Let's do that. Total in circle, counting how many times we're in the circle, right? Let's start that at 0. Okay, and we can keep track of how many times it goes inside the circle, right? And then that 100, you know what? That 100 is how many times. So how about trials equals 100, and then I can divide by trials. I can divide total in circle by trials and get the probability, right? So trials, although I probably don't want this here. Well, I could put it there, I guess, but I'm going to put it here. Okay, there you go. All right, so there you go. Whoops. Else, let's make the color RGB blue, or whatever color you want, different from the color for inside the circle, right? Okay, good. All right, now what we're going to do is we're going to draw a dot to represent where the dart hits the board. So how about draw dot function at xy with the color we just set. Aha. Okay, so how am I going to do draw dot? Draw dot, let me think, how did I do this? Well, let's do it sort of like draw circle and draw square. All right, so how about we go up here, right? Here's draw hill. Why can't I scroll? It won't let me scroll up here. Zing. Okay, so there's draw square, there's draw circle. Let's do something similar for draw dot. How about that? Define, let's make this a little bit bigger so you can see what I'm doing. Draw dot. All right, now draw dot has an X and a Y and a color. Every dot has a location and a color, either red or blue, right? Or whatever color you chose. All right, so let's do just like the square and the circle. Pen up. Let's go to X, comma Y, right? Okay. So let's go to my pen. It's not really a turtle. I'm drawing it like a pen, right? So my pen that go to XY. Alrighty. Then pen down. Because if I don't do pen up first, it's going to draw a line, like with the tail having a pen stuck to a turtle, right? So pen down now, so we can draw. Whoops, down. Okay. Let's make a very small circle. You know what? Let's do it like before. Let's go down 1 unit, right? And then we're going to draw a circle clockwise from there about the point that we have in mind. Okay. How about that? So it's sort of like draw a circle, but very small, a very small circle. And let's do a fill color of the circle, whatever the color is. So how about my pen dot fill color is the color we passed from below, from the main program, I guess. And let's make the pen itself that color. So that'll be the edge of the circle. So the pen color, or the turtle color, is also going to be whatever color we chose. And let's make a circle of radius 1, very small. My pen dot circle radius 1. Aha, good. And all right, let's see what that does. Okay, good. And you can see it running. Nice, I like it. There we go. All right, now, how about let's get the value of pi. Okay, I think this is almost done. All I got to do now is figure out my value of pi. Now remember, the probability is pi over 4. I'm going to multiply that by 4. So the total number of times it went in divided by total in circle divided by trials is pi over 4. Times 4 is our estimate for pi. And the estimate for pi will be better and better and better as we throw more and more dots. I'm only throwing 100 dots. Alrighty, so this is done except for that one thing. Now, if I do a print, does it pop up somewhere? I'm going to do a print. All right, so after all of this is done, I'm going to say my value of pi, not math.pi, whoops. Let's make it obvious. My pi is going to be 4 times total in circle divided by trials. Okay. Now, is there a problem with these are all ints? Do I have to do like 4.0 times? Well, let's find out. All right, so enter, and then let's do a print. Print. So here's my estimate for pi. Let's see. Quote, comma. My pi equals. Oh, this is Python 2, right? We have to pay extra for Python 3. So I'm going to concatenate a string version of my pi. How about that? Okay. I think we're done. So let's run it. No. What did I do? La 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 la. Oh, did I put this in the wrong place? Hang on. Let's scroll down. Hang on. I think there's some code that I should have put this. Yeah. Duh. All right. Hang on. Let's copy that. Hello. I'm going to do Control X to cut it. Get rid of that there. And then we got to put this at the bottom. What's going on? After the loop. Yeah, duh. There. Okay. So total in circle is now defined on line 37 before line 55. I put it all the way up at line 29 or something. That's crazy. All right, run that. Here we go. So 100 dots. Some might be overlapping a little bit. And there's my estimate for pi, 3.16. Now, that's not great. 3.141592.8 something, isn't it? So let's make it better. How about 1,000 dots? Now, is this with the speed is 0? Yeah, okay. So let's do 1,000 dots. Make it a little bit more accurate. Here we go. It's going to take 10 times longer then because we had 100 dots. Now you probably want to hit save. Now for homework, what I would like you to do is just get this working in your trinket.io and show me a picture of your final run. Like picture when this stops, take a picture. And so I can see your output and your estimate for pi. And you could do a different number of trials. I did 100, I did 1,000, you could do something else. All right, 1,000, you're almost done. We should probably have like a progress bar or something going on that tells me how far I've gotten up to trials equals 1,000. I might have to go and get some coffee or pizza or something here. So happy Pi Day. This is we're going to do this either on the 13th or after Pi. Usually Trinket Tuesday would have been that 13th would have been the 17th on St. Patty's Day. But of course, we were already on remote learning then, and we were too busy figuring out what we were going to be doing to be playing around with Trinket. And there's my answer now, 3.104. Okay, so you could run this for different number of trials. Usually the greater number of trials, the better. This is an underestimate. We had an overestimate before, 3.16. This is an underestimate, 3.14. The answer is somewhere in between. You can probably take the average of two different runs or something to get a good answer. And that's it. Okay, so stay safe, everyone. Stay healthy, and see you tomorrow.